So hello dear students, welcome to the new lecture of the course, and in this particular lecture we are going to see the logarithmic curve. What I had seen in most of the students, they don't understand the logarithm curve, or they don't understand the log graphically. They bluntly apply the formula and try to get the answer, but I had seen very few students, or almost negligible students, they try to think the log, or try to think the mathematical equations graphically, right? So today I am going to teach you how you should understand the graphical part of logarithm, right? So let me just write the uh, topic name, that is logarithmic curve. Logarithmic curve, right? And let me just highlight this particular thing, and then we are good to go. Let me just highlight it. So this is our logarithmic curve. Okay, so again I'm taking the equation. I know you might be frustrated by just seeing at this particular equation again and again, but again it's part of our study, so we have to do it, man. So let's suppose we have equation y is equals to log of x, and let's suppose we have base as a. So in the exponential form it can be written as a raised to y, which is equivalent to x. Again I'm copying this particular equation, and then I'm pasting this particular equation on the next page. So let me just paste this particular equation, right? So suppose I'm moving somewhere over here. Let me just highlight it with the help of one box, and then we are good to go. So now students, just think how we can plot the logarithmic graph. So for that we need we would be using this particular equation, that means the exponential form. Okay, so now let's suppose for time being the value of a is greater than 1. For time being, let's suppose your a is equivalent to 2, right? Let's suppose if your a is 2, okay, and x can be anything, like x can be anything, right? If I'm increasing the value of y, just a second, what I will do, I will write this particular equation how it will look like, and then you might be able to understand this thing in a much better way. So let's suppose, since my a is 2, so it would be 2 raised to y is equivalent to x. So as you can see over here from this particular equation, just a second, yeah, from this particular equation, if I'm increasing the value of y, my x is also increasing. What I mean to say is this, I will write over here, if I am increasing the value of y, my x is also increasing, right? So there is a proportional relation in both of them. That means if y is, let's suppose 1, I'm getting x as 2. If I'm, let's suppose if I'm taking the value of y as 2, I'm getting x as 4. As you can see, both if both the if one of the value is increasing, the other is also increasing, right? So what I will do, I will just roughly draw the x and y axis. I'll just roughly draw the x and y axis. So I will take white color. So this is your y axis, correct? And this is your x axis, right? So now what I will do, what we will do, we'll just uh, cancel this part, and we will try to plot this graph in the next page. So let's suppose this is your graph, this is your y axis, and this is your x axis, because there is one reason we need some part for calculation, right? So we have this particular equation. I will copy this particular equation again, and I will bring it down. Just a second. Yeah, we have this particular equation. Let it be over here. I will copy this and copy this to the next page. Oh, yeah, right. We have this particular equation, that is 2 raised to y is equals to x. We got this particular equation with the help of this particular equation, right? I hope that you are understanding me. What we did first, we assume that the value of a is greater than 1. For time being, we had assumed this a to be 2, right? Then what we saw from this particular equation, that means this one, a raised to y is equals to x, correct? So if the value of y is increasing, the value of x is also increasing. That means it would be a monotonically increasing function, right? Monotonically means continuously. So students, now you tell me, uh, what if I put the value of y as minus infinity? Like if I want the value of x to be 0, let's suppose if I want the value of x to be 0, just a second. Yeah, let's suppose if I want x is equals to 0, right? So for that I have to put the value of y to be minus infinity, correct? If you could see very clearly, 2 raised to minus infinity, that means I'm talking about 1 by 2 raised to infinity. And as you all know, infinity means a huge number, and a huge number is getting divided with uh, 1, so it would be obviously 0. So our x would be equivalent to 0, correct? So this is what we saw. So at minus infinity, maybe at somewhere over here, let's suppose this is minus infinity, correct? So let's suppose for time being it is minus infinity, we are getting 0 value, right? We are getting 0 value. So our graph would be somewhere over here. Let me use blue color. Yeah, our graph may be somewhere over here, correct? Now let's suppose if I want the value of x as infinity, right? If I want the value of x as infinity, if I want the value of x as infinity, so obviously for that y should also be infinite or infinity, right? So that means from this particular equation, if I'm putting the value of y as infinite, so obviously I'm getting the value as infinite, that means my x is infinite, correct? So that means what? At somewhere over here I'm getting the value of x as infinite, that means somewhere over here I'm getting the value of x as infinite, x is equals to infinite, right? I'm just drawing the graph bluntly. Further in some software we will see this particular graph, right? And now let's suppose if I'm putting the value of y as 0, let's suppose if I'm putting the value of y as 0, let's suppose if I'm putting the value of y is equals to 0, so that means 2 raised to 0, which is equivalent to 1, that means what? Our x is equivalent to 1, right? So what does that means? At y is equals to 1, sorry, at y is equals to 0, extremely sorry students, I just didn't write the x and y axis. So this is your y axis and this is your x axis, right? So what we saw over here, if I'm putting the value of y as 0, okay, I'm getting x as 1. So that means somewhere over here when y is 0, so I'm getting x as, just a second, I will use certain different color. Yeah, at y is equals to 0, I'm getting x as 1. Okay, I'm getting x as 1, correct? X as 1. Now let's suppose if I'm putting just a second, I'm getting x as 1. Let me use different color, this one. Yeah, I'm getting x as 1 for y is equals to 0. Now let's suppose if I'm putting y is equals to maybe 1, right? If I'm putting y is equals to 1, so obviously I'm getting x is equals to 2, or in our case our 2 is a, so we are getting basically over here we are getting x as x is equals to a somewhere over here when y is equals to 1. So what we can see over here, just a second, yeah, when our y is 1, so we are getting x is equals to 2. That means when y is 1, that means it may be somewhere over here. When y is 1, we are getting x as maybe 2, right? We are getting x as 2. Now if I try to join this particular point, let's suppose if I'm trying to join this particular point, I will get the graph in this way. Just a second. Yeah, I will use this one only, and maybe I will take this color, right? So let's suppose if I am trying to join this particular graph, it would be something like this. Just a second, I will take different color, so it would be little good for you to understand the thing. I will take a little purple color. Yeah, students, I'm drawing with a rough hand, so please try to understand it. After some time we'll also try to see this particular thing uh, with the help of software we'll actually plot this particular graph in software, right? So something like this. So you end up getting the graph something like this. So as you can see, at minus infinity, uh, you are getting the value as 0, and at plus infinity you are getting the value as infinity, right? Let me just erase this point because it won't be looking good on the graph, like it won't be properly managed on the graph. So what I will do, I will just roughly mark the point, so that would be easier for you to understand the things. Suppose this is the I will take this color. Yeah, when y is equals to 1, maybe somewhere over here, you are getting excess 2, right? So this is that point, so you are getting excess 2. So I'll take this color. So when y is equals to 1, you are getting excess 2. That means I'm talking about this point. And when your y was 0, you were getting excess 1, right? When your y was 0, you were getting excess 1. So I was talking about this point. And it is almost reaching to infinite, sorry, it is almost reaching to 0, but it is not 0. We will see this particular thing in the software, right? And when your y was infinite, your x was also infinite. Let me just plot this point as well. Yeah, when your y was infinite, your x was also infinite. And when your y is minus infinite, your x is almost equivalent to 0, right? Your x is almost equivalent to 0. So these are the points. Let me just highlight the points. So when your y is wait, I will take little different color, yeah, maybe blue one. When your y is equals to minus infinite, right, your x was almost equivalent to 0. I won't say it is 0, it is tending to 0. That means you might also apply a limit over here, that will also do. And over here, when I'm talking about this point, so if your y is 0, your x is 1, correct? Let me just highlight it with the help of bracket. And talking about this point, when your y is 1, right, so you're getting excess 2, or in our case the 2 is a, so you are getting x is equals to a, right? And talking about this particular point, so when you are putting y is equals to infinite, you are getting x as infinite, correct? So this is what we concluded. Again, I would like to write over here the same thing, so that whole of the picture would be crystal clear with the help of this particular graph, right? So if I'm putting the value of y as minus infinite, that means the very first condition, we are actually, what I will do, I will just give the condition. This is first condition or first case, this is second case, this is third case, and might be this would be the fourth case, correct? So this is your, oh sorry, so this is your fourth, this is your case number 1. I'll just erase this particular thing, and maybe I will use little vibrant color. Yeah, this one. So the first condition is when you are putting y is equals to minus infinite, so obviously you are getting x as 0, almost equals to 0, but it is not 0, right? And the second condition is when you are putting y, let's suppose if your y is 0, so obviously you are getting x as 1. The third condition is when you are putting what was the third condition? Yeah, when you were putting y as 1, you were getting x as 2, right? And the fourth and the last condition is when you were putting when you put the value of y as infinite, so you got the value of x as infinite, right? So we saw this particular 4 cases, and then we just roughly plot the graph. If you took the value of x as 2, 3, 4, so obviously you are getting to get a curve like this, as we are seeing over here. You need not to worry, we are also going to plot this particular graph on one software, which will actually give you a clear cut idea of how the things are going to work, right? So we will quickly revise the things what we had seen up till now, and then we will straight away move to the software to see the uh, graph or the curve, logarithmic curve. So at starting of the lecture, I just explain you this particular thing. That means this exponential and logarithmic form, I mean this logarithmic and the exponential form. And I hope now you are very much expert in this particular thing, right? I just took one equation, y is equals to log of x to the base a, and in the exponential form we wrote this particular thing in this way, that is a raised to y is equals to x, correct? And then for our understanding, what we took, sorry, what we uh, took the value of a as 1, sorry, greater than 1. For our better understanding, we took the value of a greater than 1. That means for time being we took value of a as 2, okay, for the calculation purpose. So if you could see very clearly, the equation is same. Oh, sorry, yeah, the equation is same. A raised to y is equals to x. Instead of a, we put the value of a as 2. So 2 raised to y is equals to x. So from this particular thing, we concluded that as our y is increasing, x is also increasing, and as our y is decreasing, x is also decreasing. So this is what we concluded from this particular part, correct? So this is the example. 2 raised to 1 is 2, 2 raised to 2 is 4. That means again same thing is being indicating over here. As y is increasing, x is increasing. Then we took random values. If I'm putting y is equals to infinite, sorry, minus infinite, right? If I'm putting the value of y as y raised to minus infinite, so I'm getting 2 raised to minus infinite, which is equals to 1 by 2 raised to infinite, which is almost equivalent to 0. But remember, my dear students, it is not 0. It is tending towards 0. This we will study in limits. You need not worry. But for our understanding part, I had taken the value as 0, but it is not equivalent to 0. Remember this part. It is tending towards 0, right? So what we did, we just took the random value, we plotted this particular dot over here, right? Which is actually indicating that when y is minus infinite, your x is tending towards 0. Then what we did, we put the value of y is equals to infinite. And then we saw that if we are putting y is equals to infinite, so obviously by this particular condition we are getting x is also infinite, right? So we saw that we are getting x as infinite. That means the graph might be somewhere over here, correct? Then what we saw was this: if we are putting the value of x as 1, correct? Sorry, if we are putting the value of y as 0, right? If we are putting the value of y as 0, so basically we are getting x as 1. So this is what we saw. If we are putting the value of y as 0, we are getting the value of x as 1, okay? And then what we saw, if we are putting the value of y as 1, so we are getting the value of x as 2, okay? So this is what we can see over here. And with the help of this particular dots, we actually plotted one graph, and the graph came something like this, as you can see. This is not the proper graph, but yeah, I had drawn it roughly, so please try to understand. We are moving towards the software part, and there you would be seeing this particular thing in much more detailed way, correct? And as you can see over here, we had indicated 1, 2, 3 and 4 points over here. So the first point is basically 2 raised to minus infinite. That means when we are putting the value of y as minus infinite, okay, so we are getting x as 0. And if we are putting the value of y to be 0, so we are getting 1, okay? So we had connected to these two dots. Then what we did, we put the value of y as 1, then we are getting the value of x is equals to a. That means in our case x is 2, right? So we got this two particular thing, and then we actually plotted this particular graph. Then what we did, we basically then we put the value of y as infinite, so we got the value of x as infinite. So then we plotted this particular graph, right? So I hope you understood up till here. Now what, just type over here Desmos software or Desmos, that will do, Desmos, and just click on the first site which you are seeing over here, and just do this entire process of signing up and all, and then you will get this kind of interface over here, right? After signing up, just click over here graphing calculator, and then you will get this kind of interface as you can see over here. Then click over here, as you can see the keyboard option, and over here I'm not explaining this particular thing. I would be explaining this particular thing in the upcoming courses where we will be dealing with integration, differentiation and all, so you need not worry about this part. As of now we are just focusing on the logarithmic function which we had just implemented, right? So click on the function part, scroll down, scroll little down, and you will get this function log ln, okay, exponential. In our case we need this particular thing, we don't want exponential form. This is a ln form, that means log of x to the base e. So over here the base is e, and over here you won't get any option to to enter the base. You will just get a log of x to the base 10, right, which we had seen in the first few lectures. So we want this one, right? So we'll click over here, and we are getting an option to enter the value of a. That means to enter the value of base. So we know our base is 2, right? As you can see over here, just a second. Yeah, as you can see over here, we had taken the base as 2 over here. As you can see, we had taken the base as 2. That means we are talking about this particular equation, right? So just a second. Yeah, and let's suppose we are entering over here as x, right? And then we are completing the bracket. This x can be anything, right? As the value of y increases, x also increases. And you did not to enter y is equals to log of x to the base 2. Inbuilt, it will actually take the log of x to the base 2 as y, and then it will plot the graph, right? So as you can see over here, let me just zoom the thing. Let me just zoom it out. Oh, yeah, as you can see over here, just a second, let me just bring it little down, and then yeah, as you can see over here, this particular dot, this one over here, as you can see, your y is 0 and your x is 1. See, this is 1 and this is 0, correct? So this particular dot, it is y is equals to 0, and this is, if y is equals to 0, then x is equivalent to 1, right? And at some instance, maybe if here, as you can see, yeah, over here, as you can see, when your y is equivalent to 1, just a second, what I will do, I will erase this particular part. Just give me a few moments. I will erase this particular thing and this one as well. And yeah, I will use a blue color so that you won't get confused over here. See this particular thing, this one and this one. I'm talking about this particular point. So I'm talking about this particular point. So as you can see over here, if your y is equivalent to 1, so your x is equivalent to 2, right? So this is what we actually plotted in our case as well. Just a second, let me go to that particular page. Yeah, as you can see, when your y is equals to 1, we got x is equals to 2. And talking about the next 2 points, and talking about the next 2 points, if you could see very clearly, yeah, now you would say that, sir, you told us that this particular value won't be 0, but here we are saying that it is almost equivalent to 0, right? So my dear friend, it is not 0. Let just give me a few moments so that I can explain you each and everything. So let me just zoom it out. As you can see, I'm going down, and it is approaching 0, but it is not touching the 0, not touching to 0. That means it is not becoming x is equals to 0, right? See, it is approaching to 0, but it is not becoming 0. So this was what I was telling about, right? So this is what I wanted to tell to you all guys. Here the condition of limits and all will be getting applied, so you need not to worry about that particular part, that we will be studying in the upcoming courses. See again here, if I'm zooming it out, it is approaching 0, but it is not becoming 0, right? Similarly over here, if I'm moving little up, just a second, let me zoom it out. Yeah, similarly over here, as you can see, the logarithmic function or the logarithmic curve, it is monotonically increasing. Monotonically means continuously increasing function. So basically this particular logarithmic function, it is continuously increasing function, continuously increasing function, right? So it is a continuously increasing function, and as you can see, if I'm moving forward and forward and forward, oh sorry, it is going to infinite. It is approaching infinite, but it is never going to stop, right? As you can see, if even though I'm moving so forward, if like now I had reached to x is equals to 155, this graph is increasing, as you can see. So what we concluded is the graph which we had plotted and the graph which we had seen, it is absolutely same, yeah. But there is some difference, I know, because I had drawn a little roughly, so it won't look that good for to you all guys. As you can see, I had just drawn it roughly, with a rough hand, so you might see little difference, but yeah, the graph is almost similar to what we had drawn in our case, right? So I hope you understood each and everything about logarithm. This was the last lecture of logarithm, right? So I hope you understood each and everything about log. So if you like my videos, if you like my content, so please do rate me 5 star, okay? And if you have any suggestions, if you have any feedback, so feel free to suggest me. I'm here to improve myself. Here to improve to you all guys as well. So thank you for listening patiently. I'm ending this video over here. Thank you guys.